Hello everyone, welcome back. In this video, we're going to begin our discussion of iterative statements or loops. Loops really make our programs powerful, and you can imagine why. They're the last of the three different kinds of statements that algorithms are composed of. We've talked about sequential statements, executing code one after another from top to bottom. We've talked about conditional statements, the ability to execute some code based on some Boolean condition evaluating to true. Now our last one, iterative statements, the ability to repeat one or more instructions indefinitely or a fixed number of times or until a certain value is encountered or some kind of Boolean condition evaluates to true or false. So we're going to learn about loops today. We're initially going to motivate why loops are not just important but necessary with an example, and then in future videos we'll dive into the details of using the reserved words to code up loops in C++. So let's start with our warm-up task. Go ahead and open up a file in gedit called transactionfun.cpp, and we're going to write some code that will compute the average credit card transaction for the user. So let's go ahead and write code to solve the problem. So here's the problem. Write a program that prompts the user for 5 credit card transaction amounts. Tell the user the total spent on the credit card based on the transactions and the average spent per transaction. Go ahead and pause the video and attempt to solve this. You've learned everything you need to know in order to solve it. We're just going to use this example as motivation for why we really want to use loops in our code. So first things first, we will need a double variable to store a transaction. We'll also need a double variable to store a total of the transactions, and a double variable to store the average transaction. The program specifically says, or the prompt specifically says, that the program only needs to handle 5 credit card transaction amounts. But let's go ahead and add that as a constant integer. We'll call it num transactions. And we'll set it to 5. We'll use num transactions as the denominator when we compute the average. So we'll want to prompt the user. Please enter a transaction amount. And then we'll read in that transaction amount into the variable transaction. And since total transaction is initially 0, we can immediately start accumulating transaction values in it. So we'll add transaction to the current value in total transaction, which is initially 0, and then we'll overwrite total transaction to account for this newly accumulated transaction value. Now we need to do this exact same thing 4 more times. So our instinct is probably to be a lazy programmer and copy and paste this 4 times. so that we're prompting the user for 5 total transactions and accumulating them in total transaction. Then we're ready to assign to average transaction the average transaction. So that would be total transaction divided by num transactions. Num transactions is an integer, and total transaction is a double. So we have a double divided by an integer. Does that yield floating point division or integer division? Hopefully your answer is floating point division, because we have at least one of our operands being a floating point value, which is total transaction. So let's print out our results. All right, so we'll just enter in seemingly random floating point values. Doesn't matter too much. Okay, just do a quick little check to make sure that that's in rough range, and it looks to be in range. Okay. Now our average transaction should be 161.94 divided by 5, and that looks to be roughly about right as well. We could get a calculator out and we could double check. That would be a good practice. Now, what if I told you that the prompt changed a little bit? Now, instead of 5 credit card transactions, let's say it's 500. Would you want to copy and paste this code 495 more times? Most definitely not. What if you did that? You had 500 triples of code like this in your program, and then I told you that, okay, we need to change the prompt. It needs to no longer say please. It just says enter a transaction amount. Or what if I said it needs to have a number here? It needs to show the count of which transaction this is. So the first one would say, please enter a transaction amount number 1. The second one would say number 2. The third one would say number 3, so on and so forth. That would be very hard code to maintain. You'd have to make so many changes, and your program would be so long that it would be a very, very, very unpleasant source code to deal with. Thankfully, we have iterative constructs like loops that can save the day and really prevent us from having to have these excessively long programs where we have code copied and pasted just to handle the number of times we need to do something. With iterative constructs, we can tell the construct, this is the number of times I need you to repeat this code. And that code will be grouped together based on curly braces. Just like we group together code in main, just like we group together code for the body of an if or an else if or an else, or how we group together code to belong to a switch statement. So loops are really, really powerful. This is just one motivating example here, but you can probably think of some other examples where we've had repeated functionality. I included 2 here. Anytime we're prompting the user to enter more numbers than, say, 1, we're repeating code. And then also, if you did a programming assignment where you made an Are You a Fan quiz, you had to prompt the user to enter in answers to 10 quiz questions. There was a lot of repeated code there as well. So we've gone ahead and solved this problem of prompting the user to enter 5 transactions and computing the average. And we saw that this code includes a lot of copying and pasting. In the next video, we're going to rewrite this code so that we don't have to copy and paste code for each transaction we want to read in. So I'll close up this video by attempting to help you understand the answer to the question, when is a loop needed? Really, are there any steps, are there any sequences or sets of instructions that you're repeating in your code? If there's not, then it's probably not a good application of a loop. But if it is, then you probably want to use a loop because loops will make your code shorter and make them easier to maintain. There are 3 different kinds of looping constructs in C++, the while loop, the do-while loop, and the for loop. We'll start with the while loop because it's the most common loop and it's the most versatile loop. Then we'll take a look at the for loop and then the do-while loop. Stay tuned.